Working with particles is a necessity of any 3D production, and creating something cool is a very desired skill. I want to show you how to control particle systems with Lab using a custom force field plugin. Lab implements custom force fields as a world space modifier, so we can just throw it on top of any particle system to create the desired effect. To start, let's go to the particle systems creation menu and create a spray particle system. This is just a simple setup which will allow us to see predictable results without too much configuration. So once I've created the spray, I'm going to go to the modifier panel, and in the list of the modifiers we can see there is a lab force field modifier. Once I add it in, we can see that there are some default parameters available, which are the input and the center, and if I just play back the particles, you can see that they are already behaving differently than what a default particle system would. I can just toggle this modifier on and off to show this result. And if I change my input value, you can see that we actually are affecting how the particles are behaving. So to see what's going on, let's open up our plugin to see the internal workings of the graph. And when we do that, you can see that there are a few parameters which are being fed to the output. And in short, what is happening here is we have a position which is coming in, and we have a velocity which is currently unused. And then from this position, we are subtracting another vector, which happens to be the center vector, and this is specified here using the x, y, and z coordinates. So for example, if I increase the input to get more drastic results, and if I move the center around, we can see that the particles are actually moving around in the scene. Just to show it more clearly, we can move the slider around. So what this does is essentially it creates a force which makes particles move in a direction that is our center coordinate here. And the basics of a force field plugin are boiled down to the fact that it needs to accept some kind of world space position and a velocity, and as a result it needs to output a force vector. So the force vector essentially means that at any frame this vector is going to be added on top of the particle's velocity to continue moving that particle using this force from that frame on. So now I'm going to just delete all of these nodes, and once I do that, we can see that our particle system is back to normal, so it's not doing anything. And as an example in this tutorial, I wanted to just create a fluid wave-like motion for particles, and for that we will need a sine wave and a cosine wave. So we'll use the sine and cosine function found in the math rollout of our library, and this math rollout is found actually under the system main rollout. Alternatively, you can right click and you can type in sine, and as one of the options it will give you this sine option, and the same thing can be done with the cosine. So as the input into the sine and cosine function, I will feed scene time, and if you have watched previous tutorials, you remember that to add a scene time you just right click on the inputs and select add scene time input, and what this will do is provide us with the current time inside our scene, which we can wire into different parameters. So I'm going to actually multiply this scene time by a value, just so I can control the frequency of the waviness of my particles. So I'll wire it here, and as the second value I'll just create another input into our plugin. So we have our input here, and I'll just set it to a small value like 1 for now. So this scene time multiplied by this value, I will now wire into the inputs for sine and cosine. And then I will create a three-dimensional vector. So I'll type in vector to find this option, which is it's right here, 3D vector from 3 coordinates. And as the x and y coordinate, I will feed my first I'll feed my cosine into x, and then I will feed my sine wave into y, and I will just output this as the result of my plugin. And we can see right now that it did something, but it is really having a huge effect. So let me just scrub through the timeline, and it is already doing something interesting, but it is doing it way more than we want. And it is actually becoming more and more as the scene continues, so it is kind of just blowing our particles away. So to decrease this, I'm going to add another multiplier to my force vector. So I'm just going to add a multiply node, and I will feed this vector into the first slot, and into the second slot I will feed in the other input that we have for our plugin, and the result of this multiplier I will use as the result of my plugin. So now the effect is actually decreased, but it is still pretty big. So what I will do is I will set my input to a smaller value, and I will change the frequency to be higher. So I'll change this frequency to be like 50. Well, maybe that's too much. I will set it to 5 for now, and we'll just see what happens. So it is already producing something more interesting. It is acting like a salt shaker of some sort, and with varying these parameters more. Right now, actually, we can just close this the plugin designer, and we can just continue playing around with parameters because we made our particle system so dynamic and so parametric that we don't no longer need to do any structural changes to the plugin. So this is how you create basic particle systems using Lab, and in future tutorials I will cover more in-depth and more interesting implementations of various force plugins that we can try.